able to find solutions to this quadratic inequality. Because now if I ask this question, limit as x approaches 3 from the right, so -3 from the right, of the square root of x squared minus 9, you will say, no problem, it's 0. No, because the function is not defined to the right of -3. So you will not know. With 2, that was easy. With 5 is easy. With -3 is easy. But with -3 from the right or +3 from the left, it's not easy. It will appear to be 0, but it's not. Okay, enough of that. So now let's finally talk about continuity. Continuity. Okay, so here is a function that I graph. I put my marker on paper. I never raise my marker. I finish the graph. Yes, I have to come back here and just put an arrow. This is a continuous function. Smooth, no jump, no gap, no holes, no asymptotes, vertical I mean, nothing. Continuous function. Okay, now let's look at the following. One situation here. Here's another. And here's the third one. Obviously, are these continuous functions? No. What type of discontinuity is this? We call it jump. Discontinuity. What about this? Is this continuous? You already said no. This is called an infinite discontinuity. This one is special. It's called removable discontinuity. It doesn't matter whether the function is not defined here at all or the function is defined somewhere. It doesn't matter. It's the same thing. It's removable. Why is this removable? Because the limit from the left and the limit from the right are the same. It doesn't matter whether the function is defined or not at all. So this is a special discontinuity, removable. The limit from the left of f of x equals the limit from the right of f of x. I'm going to call this a. X approaches a from the left, x approaches a from the right. Here there is no discussion. The right is one thing, the left is the different thing. Even if I have both infinities to the same side of both to infinity or both to negative infinity, is still a infinite discontinuity or discontinuity of type infinity. But this one, because I can create a function by simply filling this in with one element. Here I will not be able to. I will have to change infinitely many points. But here I can change one point and make that continuous.
So it doesn't have a limit, but it is continuous?
Which one are we talking about?
The removable discontinuity.
It's the removable discontinuity is a function. So a function has a removable discontinuity that by definition, the limit from the left equals the limit from the right. I can transform this function by changing one point, a finite number of points, and make it continuous if I wanted to. I can define a function that is continuous. Right now it's not. It has a removable discontinuity. But this is the only one I could possibly change it into a continuous function. These two, never. Was that the question? Maybe I missed something?
No, yeah, I just wanted to verify that since they have the same,
This,
the
all-
limit still is right there, so it's still at that point of A, but that doesn't make them continuous.
all these three are discontinuous. If I wanted to create a continuous function from any of these, this is the only one that is a candidate. If I wanted to create a continuous function.
Okay, thank you.
Thank you. Okay, so the most important topic here is continuity at a point. So here's a function, here's a point P, and let's say it's at A. What has to happen at this point for the function to be continuous? The limit from the left and the limit from the right, as well as the function value, they all have to exist and be equal. So limit of f of x, so this is our function f of x, as x approaches a from the left, must equal limit of f of x as x approaches a from the right, and must equal f of a. Definition of continuity at a point. The limit from the left, the limit from the right, as well as the function value, they have to all exist and equal the same number. Finally, before we look at different situations and problems, continuity on an interval. Continuity on an interval. A function is continuous on an interval if it is continuous on that interval. I need help to fill this in. So here's the interval. I presented it directly on the function. A function is continuous on an interval if it is continuous.
Or every point in the
Excellent.
within that interval.
At each point on that interval, of course. Thank you very much. Who was that?
Nick.
Thank you. So a function is continuous on an interval if it is continuous at each and every point, like this. One after the other, one after the other. No gap, no. Good. So now let's look at a few situations here. Determine whether each of the functions shown in exercises blah 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 is continuous. Okay. So let's choose. So we have 37 through 41. 41 is on the next page. So before we continue, I just want to mention one more thing because I'm going to ask you on those graphs. There is something called continuity from the left and continuity from the right. So this is continuity from the left. So the limit of the function as x approaches a from the left equals f of a. But it does not equal the limit from the right. So this is continuity from the left. We have the same thing, continuity from the right, where the limit from the right limit Sx approaches a from the right of f of x equals f of a. So this one is from the right, this one is from the left. The limit from the left and the function value. The limit from the right and the function value. Okay, let's choose anything you would like, 37 for 40, or we can look at 41. Let's see what is 41 all about. 41 is good too. It's up to you. We can come back to 41.
Can we do 37?
Very good. Good pick. Which one? I think it's 37.
Yes.
Okay, perfect. 37. Is this function continuous everywhere?
Yes.
Oh,
It's not continuous at x equals.
-2.
And what is it? Is that called?
Jump.
Jump discontinuity. Is it continuous from the left or from the right?
The right.
Very good. Let's look at 40. Is this function continuous?
No, it's removable.
Removable. Excellent. Because the limit from the left equals the limit from the right, but it does not equal the function value at that point. Great job.
What about 39? It's a smooth, continuous line, so it's not
It's not a line, it's a curve.
continuous.
Yes, it's continuous everywhere. The function is continuous everywhere. Okay, what about here? Is this function continuous everywhere?
Nope.
No. It's not continuous at
X equals -2.
x equals -2. What type of discontinuity is that?
Infinite.
Infinite. Very good. So they're asking us the same questions here, that for 37 through 41. Oh, no, this is something else. Use the graphs and functions of, yes, okay, if an expression doesn't exist, state that fact. Okay, so let's see what else we want to look at. Yeah, let's answer a couple of questions on this. 47 and 48 using the graph provided. Okay, fine. Okay, so is G continuous at x equals 3? Is G continuous at x equals 3?
No.
No. It's what type?
Jump.
Jump. Okay. Now I would like to pick a function from 53 through 55, potentially more on, yeah, okay, we have more. Good. Any function from these, and then we would like to look at a word problem. We always have to look at word problems in this class. Okay. So let's choose again our favorite.
57.
57. Okay, let me copy it and then I'll start sharing. And that is g of x equals 1/2 x plus 1 for x less than 4, minus x plus 7 for x greater than 4. And what happens at x equals 4? Why or why not? Okay. We're not asked to graph this function. We're asked to identify whether the function is continuous at x equals 4. What is the first step we have to perform here? To find the what?
The domain.
Excellent. Awesome. So we know that this is -∞ to 4. We know that this is 4 to infinity. Can anyone give us the domain?
All real numbers. All real numbers.
This is a parenthesis. This is a parenthesis.
negative infinity for union
Thank
for
you.
infinity.
Good, excellent. So then what do we conclude? Is this function continuous at x equals 4?
No.
Because it's not defined at x equals 4. Not continuous since it is not defined at x equals 4. See, the concept of the limit is not the same with the concept of a function being defined. In this case, ultimately being continuous, right? Even if these two limits are the same, I don't care. They may be. Who cares? Nobody cares. What we care right now is the fact that it's not in the domain. If it's not in the domain, even if the limits are the same, it's a removable discontinuity, but it's still a discontinuous function. Let's look at a word problem. We want to look at the candy factory or a lab technician, or yeah, you choose. Candy.
The lab technician.
Let's take a look at the lab technician. Very good. A lab technician controls the temperature T, uppercase T, inside a kiln. Okay. From an initial temperature of 0 degrees Celsius, he allows the temperature to increase by 2 degrees per minute for the next 60 minutes, which is right here. Between 0 and 60 minutes, he allows the temperature to increase by 2 degrees per minute for the next, he allows the temperature to increase. Okay, so I don't see from an initial temperature to increase by. This is 2 times T. Increase by is T plus
T is
2.
number of minutes.
Right, but after the 60th minute, yes, he allows, so the temperature increase by 2 per minute. 2 per minute. I didn't finish reading. You're right. Thank you. Thank you very much. So for the next 60 minutes. Good. After the 60th minute, okay, he allows the temperature to cool by 3. Okay, got it. If T is the number of minutes, the temperature T is given by. So I'm just going to copy this function. So this is problem 75. So T of T is 2T for T less than or equal to 60. And then 300 minus 3T for T greater than 60. Perfect. So they want us to determine 3 limits. Fine. So the left limit as T approaches 60 from the left. Okay. So limit from T of T as T approaches 60 from the left, then 60 from the right, and from either side. Perfect. Let me stop sharing now. Good. So all I have to do is determine this, but replace T of T with the correct branch. So which branch do I replace it by? Which one?
2T.
So then the limit will be?
120.
Very good. Now limit as T approaches 60 from the right. It's a silly question. It's 60 from the right. I already used the first one, so this must be the other branch. And what do we get? So this is 180. So 300 minus 180.
Oh, sorry. Yeah.
So this is degrees. Right? So what do we conclude about the limit from either side?
They're the same.
Very good. That's it.
Can we go back really quickly to question 39 because it was continuous, but then the question was asking if it fit within. It said negative 6 to 6. It was asking if it fit
So which problem are we going back to?
39.